Is website performance improved when percentile 90 is improved? So let's take a look at a website which has a baseline version. The baseline version is a version like maybe from yesterday, uh, and developers made some change to the product. And now we have an experiment version. And there are some commits added to the product comparing to the last measurements of performance. So how can we tell, or can we give an answer, is performance better when we use percentiles for this to answer this question? So is performance better or worse than regression? So should developer live in fear that he has broken the production system, and can he use or her percentiles to answer this question? Let's take a look at an example. So we've got an array with measurements. Those are latencies coming from the real system. And when you draw a chart based on that, you can see what it looks like, just like that. Now let's use the same data. However, now we can sort the array ascending. This is the same data, but you can see on the right the representation, what it looks like compared to the left one. Now we can see the big picture from the best case, which is the lowest latency, to the worst case. So you can grasp immediately what the user experience might be. In the best cases, it's like whatever it was measured under the hood. It's 1 second, and in the worst cases, it's 2.5 seconds. Let's move on to percentiles. What is a percentile? Imagine that there is an array. Let's say that it has 100 elements. A first percentile is a position at 1% index of an array. So if you have an array of 100 elements, that would be the first percentile is the value at index 1. If there would be a array with 200 elements, that would be position 2 for first percentile, 4 for another percentile, etc. If we have like 9,000 percentiles, latencies collected, you could see the relevant indexes of array to be used as values. This way, we can compress all the samples and have almost the same chart with only 100 numbers. So what would it look like? If we take the example we had, starting here, we can come from this chart to this one. And P90 would be somewhere here, well, in this case, exactly here. So now let's try to answer the question. If we use P90 or maybe P99 as well, which would be almost the worst case, and we change the system and collect the samples again, and we have the baseline P90 and experiment P90, and there's an improvement like 11% better, the latency is lower, minus 11%. Can we say that there is an improvement? Yeah, it looks like there might be one. If we compare almost the worst case, which is close to the maximum latency user experienced, there is also an improvement after modifying the production system. It's 16%. So can we say there is an improvement? Take a look at the chart, and I think you will quickly figure it out. So this is the baseline system. That's the blue one, and the experiment, which is red. And P90, as you saw here, is better in experiment, and P99 as well. Well, basically, the worst cases are better in experiment. So after developer modified the system, it did improve the system. However, for everything on the left, because percentile is not telling about anything that is going on the left of the percentile, you can see that there is actually there is a regression. So can we? I think that I hope that currently now we see that the reasoning seeing only a one percentile and comparing it to percentile from the baseline might be very misleading to conclude something like, yeah, there is an improvement, or maybe there isn't. So what if we use an average for that? Actually, it would show that there is a 5% bigger latency, so that's a regression. So now developer might be confused. So is there an improvement or not? And the answer is that, well, a single percentile might be very misleading. An average used might be also very misleading, and some other metrics should be used to compare the distributions, and that would be a topic for another video. And now it's time for a meme. But I think now it would be like easy to understand for you. So where percentile is better average change, it actually might not mean at all that the performance is better, even if you hope it is. So where does the experience I have come from? I've been a backend developer and some frontend as well for almost 20 years. And I've been working purely on performance methodology in Atlassian for the last few years. And now let's move on to an example of showing the percentile distribution on a live measurements. Well, measurements coming from a live product. Let's start with saying that improving performance of website or any product has a loop. What do I mean? First, a tool needs to measure what the actual performance is, then suggest some fixes, prioritizing them by the impact that the improvement can, how can it improve the actual performance. Then there is the developers come to the play and actually apply the fixes. And after that, on some staging system or production, measurements can be applied again to see if it actually improved the performance. And I believe that it's the best when developers or business owner can focus purely on this part, which is actually changing the product after knowing what to fix. Because figuring out what to fix, that's the hard part. Actually applying the fix is often a hard part as well. And that's what I'm working on my own tool, which is Performance Explainer, to reliably show you what the measurements looks like, what the performance really is user happy or not, and to show the fix suggestions that are really reliable, so you can be sure that after applying them, it will actually improve the performance. So let me show you an example of measuring my own blog. The measurement is first contentful paint, FCP, which is um, telling how quickly a user is sees anything on the page after it's loading. So it's the first contentful paint. And after taking 100 samples, we can see on the percentile chart, on the distribution chart, that it ranges from 1 second to up to more than three seconds. And that's only the first thing that shows up on the page. That doesn't mean the page is fully loaded yet. So there isn't a room for improvement. So what the tool is showing to as a actual performance fixes that can be applied. On the very top, you can see that the bottleneck is time to first byte, and that should be sped up by 30% in order to keep user happy with some acceptance criteria. And you can see the return of investment here, because if you speed up the time to first byte by almost 100%, which is kind of not realistic, you can see the maximum potential of this fix, which is almost 80% improvement of what user experiences. If we speed up the time to first byte like 40%, the impact would be 30%. And there's also some other resources that page loads. And the only one that actually might have might make sense to improve is some styling resource. And no other resource impacts when you speed up a single request. No other requests impact the performance. So, for example, I applied also a set of requests, but that's a suggestion coming from some other tool that tries to propose suggestion to fix the product. When speeding up these resources, those are CSS files, the overall improvement might be like 4% for every single percentile. And when you compare that to the possibilities, there are simpler ones. I mean, the single CSS file has the same impact, and the biggest return of investment is here. And if we tried to apply what other tools are saying, which is you should optimize a JPEG file, it actually would make a zero impact on the measurement, on the user experience, because this resource is not even once loaded within the measure before the measurement ends. So it's a irrelevant resource. And I think that's it. If you like this video, just leave some comment, give any reaction, thumbs ups, whatever. And if you want to try the tool I mentioned, the link is somewhere below the video. And well, hopefully see you next time.